In this video, I'm going to talk about the second part of section 1.8. I'm going to talk about multiplying and dividing in bases. And I'll also have a bit of a review of some of the concepts in the beginning part of section 1.8. So here it goes. Let's multiply 2 times 4, but in base 5. That looks like it would be awful, but actually remember that multiplication can be thought of as repeated addition. So what I'm going to do here is I'm going to add 4 plus 4 twice. Or the other way that I can do this, and both in base 5, is I can add 2 plus 2 plus 2 plus 2, 4 of them, all in base 5, right? So I can either repeat 4 twice, that's 2 times 4, or I can repeat 2 4 times. Either way will get me the answer to 2 times 4 in base 5. So let's do it this way, 4 plus 4 in base 5. Well, 4 and 4 is 8. That gives me 1 5 with 3 left over because 8 is 5 plus 3. And so here's the 3 left over at the bottom, and I've carried the 1. And that's my answer there. To do the addition this way, 2 plus 2 plus 2 plus 2 plus 2, that's a lot of 2's to add. So let me just add the first 2. 2 and 2 in base 5, that's 4, right? And here, 2 and 2 in base 5 is 4. Well, then I'm just adding 4 and 4 again. We already got that answer. That's this. Now, there's one more way I could do it. Instead of adding over and over again, I could do 2 times 4 in base 10, which is 8. And then I could convert 8 into base 5. So I can make my base 5 columns. Here's 5 to the 0, which is 1. And here's 5 to the first power, which is 5. To make the number 8, I need 1 5 with 3 left over. Same answer. It's 13, or 1 3 in base 5. Now, also in your textbook, you are asked to complete this base 5 multiplication table, and has a bunch more base 5 multiplications. So right here, we want to figure out the answer to 3 times 2 in base 5. So how we're going to do that? We're going to do that the same way we did it in example 6. So let's look at 3 times 2 in base 5. That means I'm going to do 2 plus 2 plus 2, right? So that I have 3 of them. Or I'm going to add 3 plus 3, so I have 2 of them. Either way, doesn't matter, I will get the answer. So let's try it out. So if I do the shorter one, 3 plus 3 in base 5, let's see, 3 and 3 is 6. That's 1 5 with 1 left over. So the answer to that part of the table would be 1 1. Now if I go over here to the other part of the table, this is going to be 1 1, right? With a little 5 subscript. Now over here, because multiplication is commutative, that means it doesn't matter what order you do it in. So commutative means order doesn't matter. Commutative means I could do 2 times 3 in base 5, and I get the same answer as doing 3 times 2 in base 5. It doesn't matter. So over here, I should also get the answer 11, 1 1. Now finally, what's the 4 times 4 going to give me in base 5? You try it out. Pause the video for a second and see if you can figure out how you're going to add to get 4 times 4. To get 4 times 4, I'm going to have to do 4 in base 5, plus another 4 in base 5, plus another 4, plus another 4. That is, I'm going to have to add 4 times. So let's just add these first two. So 4 plus 4 in base 5. 4 and 4 is 8. that's this, right? We already did this, so you know the answer to that. And then we have to add the second part, add them again, and I get the same answer, right? And now I have to add those two answers together to get my answer to 4 times 4. So the answer to this is 1, 3 with a little 5. The answer to this part is 1, 3 with a little 5. Let's see. 3 and 3 is 6. That's 1, 5 with 1 left over. So that's 3, 1. And that's what goes in this part of the table in the corner, is a 3 and then a 1. Now we want to check our answers by converting. So let's just check the last answer, the 4 times 4 answer. So normally 4 times 4 is 16, right? Let's convert 16. So instead of doing this one here, let's convert 16 into base 5. So we want our answer to be 16. How many 5s are there in the number 16? And how many 1s left over? Let's see, the number 16 has 3 5s in it. That's 15. With 1 left over. That absolutely agrees with what we got by addition. Now that we have our table filled out, let's look at some of the patterns you see in the base 5 table. In base 5, do the multiples of 2 still always end in an even number? So look down the multiples of 2 column, that's this column here, and see if you see the numbers and what they end in. You can see that the multiples of 2 don't end in an even number anymore, whether you go down the base 2 column here or go across the base 2 row here. So that's different. Now think about the second question. Is multiplication commutative in base 5? Is there a way that you can tell looking at the whole table and then give some examples? So let's look at the whole table. If you look at the whole table, do you see along the following diagonal line that goes right through the middle? Do you see how you get the same answer on each side of this table? That's because multiplication is commutative in the table. That is, if I look at 3 times 4 in this table, I'm going to get the same answer. So here's 3 times 4. I'm going to get the same answer as if I do 4 times 3. So here's 4 times 3. I get the answer of 2, 2 with a little 5. Either way. So multiplication is commutative. Now what about the next question, the question of identity? Do you remember what identity means? The identity is a number where if you multiply by the identity, so A, any number A, times your identity, is going to give you what? It's going to give you your original number back. So here's A, you're going to get A back. So now in place of the A, you want to put a number. So think of all the numbers in the table, like the number 2 is in my table. 2 times the identity should give me 2 back. Or 3 times the identity should give me 3 back. Where do you see that happening in this table? That's happening in the first row of this table right here. 1 times 1 gives me 1 back. 1 times 2 gives me 2 back. 1 times 3 gives me 3 back. That means that the identity here is the number 1. So we write 3 times 1 equals 3. And the identity is the number 1. Our final question asks about division. So we can see from the table that 4 times 3 is 22. That's funny. 4 times 3 is not 22, but in base 5 it is. So I should say 4 in base 5 times 3 in base 5 is 2 in base 5, right? What division facts does this give you? Well, let's go back to base 10 for a second. If I were only in base 10 and I said, I know 4 times 3 is 12, that means I know the following division facts. I know 12 divided by 4 is 3. I also know 12 divided by 3 is 4. So let's go back and say, all right, instead of 4 times 3 is 12, in this setup, I know that 4 times 3 is 2. So what division facts does that give me? It gives me the following 2 facts. It tells me that 2 divided by 4 is 3. And it also tells me that 2 divided by 3 is 4. But all of this, of course, is in base 5, right? Would not be true in our regular base 10. All right, let's try this whole idea again, but in base 8. So let's start by finding a few more pieces of our multiplication table. Let's find 4 times 7 in base 8 by repeated addition here and by converting, both methods. And let's see what else we can fill in the table. To find 4 times 7 in base 8 by converting, we would do 4 times 7. Let's see, what's 4 times 7? Regularly, it's 28, right? So we would take the 28 and convert it into base 8 using our base 8 columns. So we have 8 to the first power, which is 1, and we have 8. So how many 8s are there in the number 28? Let's see. 3 times 8 is 24. There are 3 8s, right? So that would be 24, and then I have 4 left. So 28 converts to 34 in base 8. That means the answer to 4 times 7 in base 8 is 34. And we would put that in the table. So we would put that here with a little subscript 8. Now, where else could we put that in the table? So we know that multiplication is commutative, right? So we could also put that in the table here. 7 times 4 is 34. Again, with a little subscript 8. Now, how about doing this by repeated addition instead? How would you do it? Think about 4 times 7. If you wanted to just repeat the 7, how many times would you have to repeat the 7? You would have to do 4 7s. So I'm going to do 2 at a time and then add what I have together. So in base 8, let's see, 7 and 7 is 14, which is 8 with 6 left over, right? Carry the 1. That's, wow, that looks so weird, right? So 14, which is 8, 9, 10, yeah, that's correct, but in base 8. And now over here, 7 and 7 is 14, which is 1, 6 with a little 8. And so now we're going to add our 2 answers together in base 8. 6 and 6 is 12, which is, let's see, 8, 9, 10, 11, 12. So we got 4 left over. It's 3, 4 with a little 8. And that's the answer we had before. Hey, how about that? So now we have part of our table filled in. What I would urge you to do is try filling out more of this table before you advance the video. Stop the video here and see how much more of the table you can get correct before going on. Now that you've practiced some multiplying in base 8, let's look at the patterns. In base 8, do the multiples of 2 still always end in an even number? Let's look at the base 2 columns. Here they are. Do they always end in an even number? How about going across the row? Do they still end in an even number? Compare this with what happened in base 5. When do you think it's going to end up with an ending in an even, and when do you think it's not? And how about the multiples of 4? Is there any kind of pattern here? Ooh, look at this. 4 ends in 4, 0, 4, 0, 4, 0, 4. And here, 4, 0, 4, 0, 4, 0, 4. And notice that 4 is half of 8, right? And the multiples of 5, when we're in regular base 10, end in 5 or 0, right? So that's an interesting pattern right there. And then here, is multiplication commutative if you look at this table? I kind of assumed it was as I went along, but you can also see from the table, from making a diagonal line, that here you get the same answers, 5, 2, 5, 2, 4, 3, 4, 3, 3, 4, 3, 4 on either side of the diagonal. Finally, let's try identity and division. Does the system have an identity? Remind yourself of what identity means. Identity means that if I have A times my identity, I get A back again. I get the number back again. So what number allows us to get our original answer back again? For instance, 6 times identity should give me 6 again. And if you look at the table, that happens with the number 1. So once again, 1 is our identity. Finally, how about division? Here we have 4 times 3 is 1 4 with a little 8. What division facts does this give you? It gives you 2 division facts. We're going to say 4 with a little 8 on it. When I divide it, by one of the other numbers, right? So here's 1 4. So if I divide 1 4 with a little 8 by 3 8, then what do you know that you're going to get back again? You know that you're going to get back the other number here. You're going to get back the 4 8. And similarly, you can do 1 4 divided by 4 is equal to 3. Either way, this should work to give you the division facts. And in general, if you have A times B equals C here, if you divide these two numbers, you get C divided by B equals A, or C divided by A equals B. So take a look at the textbook and see what else you think about the patterns in general, and see if you can remind yourself of how to convert and multiply in base 12, in base 8, if you didn't try that already. See you in the discussion.